All right, thanks for tuning in. Here we have lesson 1-1, identifying functions. And we're basically just going to go over the materials that we used in class, and so you can hear it, you can see it again when you need to, and you can get information that you may need to hear more than once. And you can do it on your time. Okay, so we're going to go to the next page. So let's just read what we have here for our intro paragraph. It says, here we are, right there. This algebra, this algebra course is mostly about three types of functions that occur frequently in real-life situations. In this lesson, you'll examine common situations and decide which class of functions provides the best model for the situation. You'll use the models below. You can see them here. There are 6 of them. You're only seeing 2 right now. And help you decide which type of function you should choose. You'll see that many of these situations are similar to those you have already encountered or will encounter soon. So we have our graphs here. Hang on a second. Let me go back on that. And let's move these up. Okay, here are 4 of them anyway. And you can see we're dealing with, let's see here, 3 types of functions: linear, exponential, and quadratic. So let's look at these, and let me write that down. You have linear, exponential, and quadratics below there. Okay, so, and then we're dealing with an increase or a decrease. So you can see here, linear increasing, it's going up and to the right. Linear decreasing is going down and to the right. Okay, exponential increasing, hang on. Exponential increasing we have right here and right there. And here we have some quadratic functions. And you can see they're different from the other 2. We have a shape here. It's opening up, and this one opens down. So let's look at the example here. The student council is selling t-shirts to raise money for their class trip. If the student council charges too little, they'll make almost no profit. If they charge a reasonable price, then they'll make a good profit. If they charge too much, fewer people will buy the t-shirts. The profit the student council makes is a function of the price that they charge. What type of function best models this situation? But first we have a label the axes and then sketch the graph. So for those of you who need a little refresher, we always have our x-axis coming across here horizontally and our y-axis over here. Some people like to think of y to the sky. I'll give you some time to think about that. Okay, let's look at guided practice number 1. Naomi earns $12 per hour in, it should say, her landscaping job. And the amount of money that she earns is a function of the number of hours that she works. Which type of function best models the situation? Again, label the axes and sketch the graph. So we have x, we have y, let's see, and we have hours, and we have money. So at 0 hours, you have $0, and at 1 hour, you have $12. 2 hours, you have $24. So on your y-axis here, you have 2, 24. Each dot is going up by 24. Each one this way is going up by 1, increasing by 1. And you end up with a line that goes like that, straight. So which type of function best models it? It is linear, increasing. So guided practice 2. That deals with some people in a local town who got swine flu increased by 40%. So if it increased, we can narrow this down to either exponential or linear, because those are the only ones that we looked at so far. And since the difference between linear and exponential is the rate of increase, we know that it's going to be exponential increasing or linear increasing. So this is a little bit different from the landscaping, where you had an hourly rate and you work so many hours, you get so many dollars. This is using a percent, 40%. So 40% of 100 is different from 40% of 200. So you're going to have a graph that is exponentially increasing in this case. So it's going to be something like this. But label the axes still, y and x. Okay? Let's see here. We'll look at this one. Carissa designs a skateboard half pipe that slopes dramatically on the side. So we have Carissa designing a skateboard half pipe that slopes dramatically on the side edges. The slope is near the bottom of the half pipe. It's more gradual. So just to visualize a skateboard half pipe in this one, and we have something like this. We'll label our axes again. And this is quadratic. We'll describe this as opens up. It's kind of like a smile, right? Okay. Let's see, you have guided practice 4 and guided practice 5 here. I'm going to leave those ones for you to work on. And that's it. So we just did most of lesson 1-1. And thanks for watching and listening. And we'll see you in class.